welcome all the panelists. We had very interesting presentations and different insights into the different processes. So there's a general question open to all. And that's what new advancement in technology taken place for metal cutting and forming for varied applications to help reduce machining time. I would ask Mr. Ravichandran to share his views.
The improve in laser power, like earlier 2 years back or 3 years back, we have never heard of anything above 8 kilowatt or 9 kilowatt. Now the world is going like 60 kilowatt and 80 kilowatt being used for cutting metal. So we see a wide opportunity in shifting of technology and process, which can give like minimum waste and higher productivity in terms of output. So that's the latest change in technology in terms of metal cutting, where the laser power has gone up high as 50, 60 or 80 kilowatt, which is being used. That's one thing. And the second thing is full automation of the shop floor, like right from material into product out. That's picking up all over, like with the major players right now who make the products. So that's another upcoming trend, what I see.
Thank you for sharing those aspects. Mr. Daniel, what are your views about this?
When it comes to metal cutting, specifically in the discrete manufacturing domain, uh, the one that is mostly spoken about is how fast and how much of material you can remove, which is essentially there's a term for it. It's called material removal rate. So if your MRR is high, it means that your process is optimal. And similarly, in these lines, there are certain technologies. I mean, we've been speaking of technologies like dynamic machining, where you engage a very small part of your tool into the material, but at very high speeds. And then the kind of motions that the CNC machine takes is not linear, or it's not something that ends with a sharp, turn. So controlled engagement, high feeds, and engagement of the entire length, sometimes of solid and solid carbide tools. These are known to mathematically as well as practically deliver the highest material removal rates, and that's what's most of our customers use to bulk out these materials.
Thank you for sharing those insights regarding bulk material. Mr. Vinayak, what are your views about metal cutting, forming, and you were talking about the bending?
Mr. Doraiswamy mentioned is coming to metal, tube bending processes also. All our machines can be equipped with automatic loaders for unloading. A bend tube is not easy with a normal standard loader, so normally a robot is used. We manufacture manufacturing cells which involve end forming machines on one side, straightening and cutting, and then bending, nut insertion, and all those processes are automated. Then recently, we also demonstrated an interesting application where on a laser tube cutting machine, we were marking data matrix code. Then the laser cut tubes were unloaded onto an AGV. AGV was taking it to the bending machine, and the bending machine, it was unloaded onto the bending machine's loader, and the loader would read the data matrix code, which would contain the part program and the data, which part is to be bent from that tube. And the bending machine will pick up that information and automatically bend the part. So from a series of tubes, which are different parts were being bent one after other. So this kind of automation is called for, but I would like to know from other panelists, because I work in a different environment here, what is the interest for this kind of automation in India? I mean, I am putting this question, but Mr. Gopalakrishna, if you wanted to continue with your discourse,
Definitely,
please go ahead.
Yeah, definitely, we would seek the answer from one of the panelists. So, continuing the discussion, Mr. Pritesh, what are your views about the advancement?
Yeah, thank you very much for the question. I think we already have some very good insights. I tried highlighting this in my presentation also, and I was just listing down when you asked this question because I knew you will ask this to me as well. So first one, what I can think is about advanced laser cutting. So I think the laser cutting technologies are kind of advancing in terms of high power lasers, improved beam quality, faster cutting speeds, and all those things. Then second, what I can think about water jet cutting. So it's also gaining traction in terms of ability to cut a wide range of material, including metals, minimal heat affected zones, etc. Then third point, which I noted is in terms of electrochemical machining, ECM. And why ECM is gaining attention is because ability to cut intricate shapes in hard metals, etc. So these three, four things I can think of, including with additive manufacturing, which I detailed in presentation.
Thank you for sharing your views about ECM also. Mr. Pritesh, coming to you back again, you were talking about the bulk metal and sheet metal touching the automotive component also. And you talked about the industry 4.0. So how the industry 4.0 is impacting the bending or the metal forming processes, deploying technologies, and you were talking about the sustainability also.
This industry 4.0, I think, not a very new term. All of us, I think, when we started our career, we have been talking about industry revolution, whether we called it industry 4.0 or not, in which we say top to bottom, top layer to bottom layer integration, etc. Now, in terms of, technology, I think we have already identified one is the accuracy, second is the time by deploying these technologies, and, first time right. These are the three good outcomes which industry 4.0 technologies can achieve. In terms of technology, it's machine learning, cloud computing, edge analytics, digital twins. These are some of the ones which are, I think, being implemented a lot.
New technologies have to be implemented for the processes also. Coming to you, Mr. Ravichandran, you are talking about the oxy-fuel and plasma and laser cuttings and automation for material handlings. So what are the common challenges you encountered, like automation for the metal forming processes?
I would say the future is automation, but how far people are accepting is a big question mark. Right now, only the big corporates who are looking at lean manufacturing right now, they are actually like they are into automation, but the cost of automation is slightly pulling them down. But some people are actually ready to experiment it. So the best thing is storage and retrieval. Automatic storage and retrieval systems have been widely accepted in all the other type of industry. But in the metal forming industry, the acceptance is slightly lower. But in my opinion, maybe in a couple of years, that will be the order of the day. People would like to switch over to automated storing and handling systems. So it's like uh, they have to see the benefits on a larger scale, not on a small, like investment to return is not the right way, but how beneficial it is. There are a lot of, instead of the direct benefits, there are a lot of intangible benefits that, like improving the productivity, which they have to feel like. So the market is yet to experiment the benefits out of metal handling, and slowly, like I feel this year, we are like in from Mesa, we are getting a lot of inquiries, and we are talking to a lot of people. Now people are slightly open, like to experiment on the material handling.
Certainly, Mr. Ravichandran, benefits of automations have to be realized, and we have to progress in those directions. Mr. Daniel, you talked about the robotics and additive manufacturing and the lightweighted products, as well as it touched upon the hybrid manufacturing aspects. So what role does CAD/CAM software play in optimizing this metal cutting and forming operations for hybrid approach in particular?
It's an interesting question on many different fronts because there's this old adage which goes, what came first, whether the chicken or the egg, right? So similarly, we tend to ask ourselves whether it's the CAD/CAM product that's leading innovation in manufacturing, or is it the machine tool that is leading innovation in manufacturing, or is it the control system that is leading the manufacturing? I think, in essence, the way we tend to do these, go about with innovation, is to partner with leading companies to try and innovate a solution together. And very specifically with the hybrid manufacturing front, it has been nothing different. It has been exactly this is the modus operandi for finding value additions in hybrid manufacturing. The CAD system or the CAM system works alongside the control system and the allied partner, the machine tool, which is essentially trying to combine a very high thermal application within a highly precise machine which hates heat, right? So combining these two together in one system to try and add material and cut material while maintaining tolerances. And typically a CAD/CAM system gives you the feedback in terms of how the motion is supposed to be, how the CAD is supposed to be formed, because there are different substructures. There are many terminologies when it comes to additive manufacturing. You are managing that on the CAD front. The CAM front is not only giving you routines to create this substructure and the part, but is also generating subtractive codes so that the near net chip is then shaped to the precise part. So a lot of technologies, whether it is involving near neighbor, algorithms on the software development side, whether it is heat dissipation, the use of high-speed machining to try and flush all the heat away with the chips, so that you don't end up hardening the workpiece and stuff like that. All of these are innovations on the CAD/CAM front. But with the rider that, it is done in conjunction with what the machine tool and the allied partners are, trying to project and solve together.
Definitely, Mr. Daniel. So we have to find the solution together.
I think that's the gist of it. Yeah.
The gist of it. Mr. Vinayak, coming to you, we're talking about the tube bending and metal forming things, and things are getting compact, and so the components. That's a very good line you said. So how do you envision AI to automate CNC machining to control movement and operation of metal forming like bending in your?
I can't talk much about it, but we are already using AI and ML both.
Next is, what new materials are being found for this automation process for tube bend manufacturing?
We are using different materials for bending tools, because the materials for tubes, there are aerospace materials like Inconel and Hastelloy and all those things, which we have been bending them for last few years. We have supplied machines to Airbus and other aerospace manufacturers with stringent requirements on quality of bend, etc. But we have been experimenting with new techniques to manufacture bending tools in shorter time and with medium life rather than very long life to reduce the costs and all these things. We are working on that. But again, it depends on which industry sector you are talking to, because an automotive, they want to produce millions of parts of the same type. So their requirements of automation, cycle times, and everything is totally different compared to an aerospace environment, and which is totally different than furniture requirement. So the requirements are different, and we try to address these different requirements in best possible manner.
Different requirements and applications need different sort of material, you mean to say?
Materials, machine configurations, you can say.
Everything is.
Now, for example, in laser tube cutting, there is more and more demand about cutting non-standard tubes like profiles which are very strange shapes, which are used for example, tractor cabins or off-road vehicles or door frames and those, which probably 20 years ago we would not have imagined that we will be able to cutting this kind of materials on our laser tube cutting machines. But now H-beams, our biggest laser tube cutting machine can cut up to 600 millimeter dia tubes. So it is widely used in steel structures, and a lot of challenges which came from that area were not known to us earlier, because those tubes are they weigh a few tons, and to handle them properly, to load them properly and unload the cut part and do everything automatically was a challenge. And
Yeah.
but
Thank you very much.
we have
Mr.
hundreds of
Black.
machines installed, so we can
Yeah.
say that we have successfully taken that.
Thank you very much for sharing that knowledge. Mr. Ravichandran, coming back again to you. So what are the new tool trends taking place in laser cutting or thermal cutting technologies? Please talk about the tool trends taking place for the laser cutting technologies.
The new tools which are being used now is beveling.
Okay.
Beveling has been like earlier much more emphasized were on the vertical cutting. Now the secondary operations like the edge formation is also looked into in a greater aspect, and now beveling is happening in plasma and also in laser. That's the new tool which is being like everybody are trying to incorporate into their machines.
That's quite nice to hear about the beveling. Now, lastly, coming to Mr. Daniel, when we talk about all these processes and upskilling initiative to maximize performance, so what are your suggestions for training skills?
Your question is meant from the skilling point of
Skilling point of view.
Yes.
Because how do you intend to develop new skill sets to operate the CNC machines, precisely to say that?
I mean, it's a valid question. Thanks for asking that, because ultimately the tool is as good. Going back to Mr. Joshi's reference, the piano and the musician who plays the piano. I think it finally boils down to that. As to the tool is as good as the user of this tool. One of our focus has been, again, to collaborate with as many educational institutions as practically possible to try and take this education from the developers of such tools to the students. And this is at the ground level. The primary way of transferring knowledge. The other way is interacting through a highly organized learning management system. For example, Mastercam University is a on-demand, online, presence with my colleagues who have experiences anywhere between 35 and 40 years in CNC technologies and CAD/CAM, who have curated thousands of hours of video content. And this is all on demand, and it is not restricted to anyone. It is free of cost. Anyone in the world can sign up within a matter of seconds, get online, download a version of the software, which is for home usage, and then learn at their heart's content, until they are able to master each of these, sections or subsections within the software. And finally, the third option is where, through our highly trained application engineers, we make sure that we sit with customers. We make sure that training is not an obstacle, but rather an enabler. So, people vote for training and, 3 days, 5 days, 10 days, and, you stop at 10 days. But if your training does not enable people, your tool is useless. And therefore, we go above and beyond this, boundary of restricting training. And we make sure that the person is able to apply to the best of their ability so that it can translate into real world savings for their organizations. And this is our philosophy of skilling, training, and enabling end users to make the best of our tools.
Thank you very much, Mr. Daniel, for sharing the skilling part. Now coming close to the session, we had very interesting discussion. I would request to Darshna, please close the session.
We hope you have enjoyed the session thoroughly. Before wrapping up today's session, we thank our distinguished panelists, Mr. Ravichandran Duraswamy, Mr. Pritesh Singh, Mr. Vinayak Joshi, and Mr. Daniel Radavi. I would also like to thank Mr. Gopal Anand for taking this initiative. We request our delegates and viewers to stay connected with us on our social media handle. OEM Update magazine is also available on Facebook, Twitter, and Instagram. You can download our app from Google Play and App Store. With this, we want to announce the closing of today's session. Please stay tuned for more such sessions. Thank you and goodbye.